Hello everyone, welcome back to Sai Homeschool. Please like, share and subscribe my channel. Last class we discussed some chemical reactions of organic compounds. That is, what are the chemical reactions we studied is combustion reaction, then oxidation and addition reaction. So now we will see another reaction, chemical reactions of organic compounds. It is substitution reaction. Name itself indicates substitution means so any one of the atom will be replaced by another atom. So that is substitution reaction. So I'll explain with the example. So if you take here, so if you observe what is this? Methane, then it will be chlorine we have to take. So what we have to do here, you write CH4 it is, right? So instead it will replace, chlorine will replace one of the hydrogen atom. So one hydrogen atom will be removed and one fluorine atom will be added here to this. So we will check. So in the presence of sunlight, chlorine is added to the hydrocarbons. It is a very fast reaction. So chlorine replaces hydrogen atoms one by one. So if you take this is called a substitution reaction. Means here what will happen? One of the atom means it is chlorine can replace the hydrogen atom. So any one atom replaced by another atom. That is substitution reaction. If you take a CH4, add chlorine to this. So in the presence of sunlight, what will happen? Here one hydrogen atom will be removed. It will then chlorine atom will be attacked. So you will get a CH3Cl. So this reaction will be takes place in the presence of sunlight. That is substitution reaction. So here what will happen? One of the hydrogen atom will be replaced by chlorine atom. So then some important, so here if you observe the carbon compound, which we are, chapter name itself carbon and its compounds. So most important carbon compounds are ethanol and ethanoic acid. So we will see some properties of ethanol and ethanoic acid, how it will be reacts. So we will check. So many carbon atoms are invaluable to us, but we will study the properties of two commonly important compounds. So these two are commonly in the nature we are using so that we will see. So it will be many carbon compounds, it will be organic compound, it will be present. Here only important that we will see here ethanol and ethanoic acid. So first it is properties of ethanol. So if you observe the properties of ethanol, so ethanol is a liquid at room temperature. That is, so here the melting and boiling points of ethanol you should observe. Then ethanol is commonly called as a alcohol. It is, and it is active ingredient of all alcoholic drinks. So ethanol is ethanol. Nol itself we know that when alcoholic group present, then it will be a OH. It will be present. When OH it will be present, it is a alcoholic group. So alcoholic group present means what we will write at last? O L. Nomenclature we studied, that is ethanol. So it is commonly called as a alcohol. So it is liquid at room temperature. So if you take a pure ethanol, that is absolute alcohol. That is called absolute alcohol. So intake of even small quantity of pure ethanol if you take, that is absolute alcohol. So if you observe here, in addition, alcoholic drinks along with that this ethanol will be used because it is a good solvent. So it is used in the medicines such as tincture, iodine, cough syrups and many tonics. Ethanol is also soluble in water in all portions. So it is good solvent. So it has the capacity to dissolve all the substances in it. That is, it is a good solvent. So everywhere it will be using. So consumption of small quantities of dilute ethanol causes drunkenness. That is, so if you take small quantity of dilute ethanol means it is a pure, it is absolute alcohol. So you will get a drunkenness. That is properties of ethanol. So what are the reactions of ethanol? So how it will be react with metal? So first, if you take a ethanol is already now we studied it is a alcohol content. So if you take a ethanol react with metal or maybe another one more. So it will be react with dehydration of alcohol. So both the reactions will see reaction with metal, that is sodium. Here we are taking a metal sodium. So here it is a ethanol. So if you observe CH3, here it is a carbon having a single bond in it is OH group, it will be present. It is OH, that is ethanol. So when it will be react with the metal, so what we will get? We will get sodium ethoxide and H2. So we already studied when this react with metal, it will give a salt and hydrogen gas. Sodium leading to the evolution of hydrogen. So alcohols react with the sodium, it leads to the evolution of hydrogen with ethanol. So other product we will get it is sodium ethoxide. So what will happen here is, so this Na will come and attack here. This hydrogen will be removed. That is, so when metals reacts with ethanol, we will get sodium. That metal here we are taken is sodium. We will get product sodium ethoxide and liberation of evolution of hydrogen gas. Then hydration, hydrocarbon unsaturated reaction to give unsaturated hydrocarbons. Heating ethanol at 443 Kelvin with excess of concentrated sulfuric acid, it will in the dehydration of ethanol. So first reaction is reaction with sodium. Second it is dehydration of ethanol. So it is very important, dehydration of ethanol. So when the dehydration of ethanol will be takes place, we have to heat the ethanol at 443 Kelvin in the presence of concentrated sulfuric acid. We will get CH2. CH2 here. Why we will get double bond here? When we will get a CH2. CH2 single bond CH2. If you observe this reaction, this product if you observe. So here around the carbon how many bonds it will be present? Here CH2, one hydrogen, another carbon bond having, it needs another one more bond. Here also it is CH2 means carbon on the carbon, it should be 4 bonds, it should be present. So but here 2 hydrogen atoms, here 2 bonds, one with this carbon atom. So here it will become a only 3 bonds around the carbon. We need one more bond. What we have to do is, for both the carbons, we have to take another bond, that is, so we will get. So this concentrated sulfuric acid can be regarded as a dehydrating agent which removes water from the ethanol. So if you observe here, so if you take here H2SO4, what will happen here? One hydrogen atom from here, it will come here and it will become a, it will not remove, we cannot remove this hydrogen atom, it will be, so here one hydrogen atom from this means water molecules, dehydration means water molecules is evaporating. That is H plus and OH minus ions will be present here. What we have to do is OH, it will be present in this. We cannot able to take H from here. So here it will replace one hydrogen atom here. Then it will become a H2O. That is dehydration of alcohol. Next, another organic compound, it is ethanoic acid. So we already know ethanoic acid means oic acid, which it will be present. What is the functional group present is carboxylic acid. So that is COOH. Ethanoic means it means two carbon atoms. It is CH3COOH. This is the formula. We should write two carbon atoms have single bond between this. Then it is the COOH functional group. It will be present. It is ethanoic acid. So reaction we should. So ethanoic acid is commonly called as a acetic acid. So it will belongs to acids group called, that is carboxylic acids that we saw above. So solution of acetic acid in water is called vinegar. That is, so when it will be mixed with the water, then the solution we will call it as a vinegar. It will be widely used as a preservative in pickles. So the melting point of pure ethanoic acid is 290 Kelvin. Hence it often freezes during a winter in cold climates. This gives rise to a glacial. This gave rise to its name, glacial acetic acid. So the melting point of pure ethanoic acid is 290 Kelvin, and hence it often freezes during a cold climates. So this it will be rise. This gave rise to its name, glacial acetic acid. So here we know that ethanoic acid is also called as a acetic acid, and also when it will be mixed with the water, its solution of acetic acid is called a vinegar. So when it will be freezes during winter, this gave rise to its name, glacial acetic acid. So the group of organic compounds are called carboxylic acids. So how this it will be happen? So one reactions of this ethanoic acid we will see, that is main reaction, it is esterification reaction. So what is esterification reaction? Means formation of this ester. So formation of ester we will call it as a esterification. So esterification, how the ester we will get it? So if you take a ethanoic acid and ethanol, so above we studied ethanol, that and ethanoic acid. So when ethanoic acid and ethanol, acid and base react, what we will get? Salt and water. Right, here also same thing we will get. So when this ethanoic acid reacts with the ethanol, we will get ester and H2O. So if you take ester and add H2O, add water to this, again you will get the products what we have using to get ester. Again we will get by adding a water, so that it is reversible reaction. So we can take ethanoic acid and ethanol, we will get ester and water. When this ester again add into the water, it will get again ethanoic acid and ethanol. So esters, what are esters? Esters are sweet smelling substances that is used to make perfumes and some of the following flavoring agents. So it is a sweet smelling substance naturally present in a fruits. That is ester, sweet smelling substance, but it is naturally present in a fruit, so that it will be used in a flavoring agents. That is ester. So that is, so if you observe here above what we studied, that is ester can be converted back into alcohol and sodium salts of carboxylic acid. This reaction is known as saponification. So another, so reversible reaction we said no here. So ester can be, this reaction can be reversible, then it will be back to acid and base. That is called saponification reaction. This saponification reaction is very important. What we have to do is, we have to take ester. See here if you observe, so we have to take a ester, then we have to add NaOH, we will get ethanol and sodium acetate here. So we will get the reaction back. Then reaction with the base, like mineral acids, ethanoic acid reacts with the base such as sodium hydroxide to give salt and water. So here NaOH when reacts with ethanoic acid, we will get sodium acetate and water. So we know that, so we have to know opposite reaction of esterification is called a saponification reaction. In this saponification reaction, instead of using H2SO4 acid we are using, here we have to use a NaOH. How does ethanoic acid react with carbonates and hydrogen carbonates? So reaction with carbonates and hydrogen carbonates, you have to take a ethanoic acid, you have to take a acid. We studied first chapter, second chapter, we revised everything that when it will be reacts with acid, reacts with base, acid reacts with carbonates, acids reacts with metal carbonates, metal hydrogen carbonates. So what we will get is product salt, water and carbon dioxide. So this is important in your acids, bases, salts and also in this chapter. So when carbonates and hydrogen carbonates reacts with the acids, that is here ethanoic acid, you will get sodium acetate, water and carbon dioxide for both sodium carbonates and sodium hydrogen carbonates. So final topic it is in this carbon and its compounds is soaps and detergents. So how it will work? So you should, how the effect of soaps will, so we are using a soaps in our daily life. So how it will be? So oily nature and oil does not dissolve in water, but by using molecules of soap, sodium, potassium, salts of a long chain carboxylic acids, this ionic end of soap interacts with the water, the carbon chain interacts with the oil. So when we get these soap molecules that form a structure called micelles, that is, so what will happen? One end of the molecule towards the oil droplet while ionic end faces the outside. So this emulsion in water soap micelle thus helps in the pulling out the dirt in a water and we can wash our clothes clean. So if you observe, how to wash the clothes by using a soap, so how it will form a, how it will helps to use the, remove the dirt. So if you observe here, so here ionic, so here if you observe that pulling of dirt in the water and wash the cloths while the ionic phase ends outside and one end of the molecule towards the oil droplet. So here see if you observe dirt it will be present on your cloths. So ionic end it will be present, no? That by using this how the soaps will helps to clean the dirt. So this ends the carbon and its compound chapter. Thank you for watching. Please subscribe for my channel.